All right, how's it going? I'm Daniel Ward. This is Breaking the Prime Directive using C Sharp for IaC to put .NET on AWS. It's a bit of a mouthful. I'll explain what that means in a moment. This is for SciFiDevCon 2024. And my idea with this talk was I've been watching Star Trek lately, Deep Space Nine, really enjoying it. And there's this idea in Star Trek of Prime Directive, which is where if they find like an alien civilization or a race that hasn't made contact with the outside world yet, they're not allowed to contact them. They're not allowed to give them tech or tell them there's an outside world or help them get there. They are not to interfere at all, and that's the Prime Directive. So my idea with this talk here is that sometimes it feels like .NET and AWS are kind of alien worlds to each other, right? There's another Prime Directive going on there. So if you're using .NET, you're probably not on AWS, and if you have stuff on AWS, you're probably not using .NET, at least not in a big capacity. And there's exceptions to that, but I think that's the general rule. Just kind of wondering if we can bridge that gap somehow, because I think at this point it's mostly cultural. That's the way the momentum has gone, because maybe in the past there were technical limitations that aren't really there anymore. So that'll be this talk. Can we, find the benefits to .NET on AWS, find how to do it? Is it easy? Is it worth it? All that good stuff. An overview of this talk is, again, we'll talk why .NET on AWS, some of the tooling and tooling options available to you in the community you can find out there for resources. I will mention .NET ahead of time compilation. A lot of this presentation will be on the AWS Cloud Development CDK, and that'll be a lot of the demo. And then I will go into the coding demo showing some of the CDK stuff. I will not cover things you'll need that I'm going to show in the demo, like setting up an AWS account, setting up an IAM user that you'll SSO with, or installing command line stuff like CDK, the Lambda tools, things like that. Because frankly, I just only have so much time I want to spend on this presentation that I want it to last. And I suppose this will be more of a 201 than a 101. This will be how you use CDK, how you can do your infrastructure with C Sharp and use C Sharp for your apps. A little bit about me. I am a software consultant and developer at Lean Techniques. I'm the co-organizer of the San Antonio Austin .NET user group, which is, that's one group. You can find me at my blog, daninacan.com, mostly a .NET technical blog, or on the socials. So please do add me if you had feedback or you enjoyed it, you had questions. It would be awesome to hear from people that found me from this. So why .NET on AWS? Well, the very first bullet point there, you'll notice I have starred, and that's because I think it's the most important one. .NET and AWS is already what your company is using. That's already what your devs are familiar with. And there's a very real and very big cost associated with using tools that your devs are not familiar with. That's, potentially a year or two of, really getting comfortable with it. If you're comfortable with one cloud environment and move to another, a lot of the concepts are the same, but they just have to learn this service correlates to this one. And if they're used to .NET and go to another language, well, your ecosystem and maybe your IDE are totally different. You're just not familiar, you're not confident with it. And all of these reasons, when you really boil them down, they're all going to come down to money, right? What's the cheapest options? Maybe we ship features out quicker. Maybe it costs less to do that. Somehow, some way, it's going to come down to money. Also, maybe this was not the case when AWS first launched many years ago, but AWS supports Windows environments pretty well. You can have EC2 instances that are Windows. Like we're going to see, you can perfectly just fine just run C# stuff on Lambdas. There may be some exceptions out there. I'm not aware of any Windows cases that don't work on AWS. And then some of the .NET tooling provided for you for running on AWS, and we will mention those as well. So one of those things is the AWS managed Lambda runtimes. And these are things that AWS provides for you. And in the case of .NET, they do runtimes for all the LTS.NET versions, which is all the even numbers. So they just came out with 8 pretty recently. And this is basically a runtime, like an environment that is all set up ready, in our case, to run .NET 8. You can roll your own, but it's just nice to have it out there already. It's less work. There are IDE and CLI templates and a bunch of templates, honestly, and some tools if you want to like deploy from your IDE or from the command line and stuff. We're not going to deploy that way because we're going to deploy with CDK. But I want to mention the option in case you want to go check that out. .NET Lambda annotations we will look at in the demo. These do a variety of different things. Sometimes they save you a bunch of boilerplate. Sometimes they help you do things that wouldn't have been possible before, unless you roll a bunch of custom code. These are pretty cool. Community. By the way, as you can see, there's a bunch of links on these slides. I'll post this presentation on my blog afterwards. So if you want to go in and find this PowerPoint on there and click on the links on there, you can do that. So AWS actually has their own like .NET community page where they link you to a bunch of these things. But there's the .NET on AWS show that's on Twitch. I believe this last episode had Norm, I think, I can't remember his last name, but he does a bunch of the .NET on AWS stuff. And David Fowler talking about Aspire. The .NET on AWS Twitter account, they retweet a bunch of things that people in the community are posting about. AWS is actually a sponsor of the .NET Foundation. Serverless Land has some good content out there. And then just the AWS blog posts, some really great content about how to do .NET specific things on AWS. So I will not be showing native AOT in the demo, but I wanted to mention this because as of .NET 7, you can publish AOT to Lambdas. And a very quick rundown, if you are not familiar with what AOT ahead of time compilation is, normally in .NET, you do a just-in-time compilation, which means you write C#, it gets compiled down to intermediary language, that IL gets shipped, and it's compiled to the machine's native code at execution time, which with a just-in-time compiler. And then finally, that native code is what gets ran. Well, with native ahead of time compilation, your code still gets compiled down to IL, but then at publishing time, you choose a target like Windows x64 that you want to publish to specifically. And it will, the AOT compiler will compile specifically for that target environment. And then you ship that. So the advantage is that it's faster, obviously, right? But there are some things you need to be aware of, like you have a bigger artifact usually, sometimes like reflection isn't available to you. But it's just cool that you can do this on Lambdas if you need that option. Important thing, I think, is that in their blog post, they claimed in their benchmarks, they found up to 86 improvement in the cold start times for Lambdas. There's another, this was only when .NET 6 was out, I believe, but Martin Costello has a pretty good, fairly good length blog post he posts his own benchmarks on there, what he found. Okay, so this is kind of getting into the meat before the code demo. The cloud development, CDK. What is the CDK? So it is a way to create CloudFormation, which is infrastructure as code, Amazon's. But you create it by writing in a programming language that I've listed there. In this case, we're going to do C#. So the benefits of that, obviously, are all the benefits you normally get with the programming language. So you have familiarity, you know how to use C# already. There's not anything new to learn except like the types that are coming in from these new libraries. You get IntelliSense as you normally would. It's still just plain old C#. Same thing with the type safety. You can even get, Copilot works with it, right? You can get suggestions as you normally would. They also have this concept of constructs, which are essentially, they're sort of like classes and object-oriented. It's a way of grouping one or more CloudFormation resources together. And by doing that, you can get some good best practices and patterns that are used a lot. You can get those both from AWS, and you can create them for your own org. You can create custom ones. And if you're using the AWS ones out of the box, you don't have to set every single property because they try to set these sensible defaults. So if you're making a Lambda, you don't have to specify the memory usage and the timeout and all this for every single one. The default values are probably going to work for you. And they divide these constructs into 3 levels. You will mostly use level 2s. Level 1s, you should try to only use when you really need to make things like those granular settings. One level 1 resource correlates to 1 CloudFormation resource. So the example here is CloudFormation bucket. You will make only the bucket. Whereas with a level 2 one, example here is just bucket. That's what you usually do. Well, you'll make the bucket, and you might get like some IAM stuff that you need for the bucket to work to go along with it that you'll almost always want. And then level 3, you won't use as often because they're more specific. But if you want that specific use case, they're very handy. So the example here is application load balanced Fargate service. And if that is exactly what you want, it's a lot less code for you to write. But normally, I think the L3s that you use are going to be custom ones that you write or your company has written for you. And we'll sort of take a look at an example of that in the code demo as well. So again, I'm not going to go through installing or how to install all this stuff. It's pretty simple. I think maybe all of these are just one-liners in your command line. The only thing you might notice on there is that we need Node.js, even though we're using C#. So hey, what's up with that? I don't want to use that stuff. That's why I'm using C#, right? Well, you don't need to know this super in depth, but the CDK is made with a library called JSII. It's open source. You can go and check it out on GitHub. And JSII, the way it works is you write a TypeScript library, and it exposes the public API of the TypeScript and exports that to these other languages. But it's really just a facade. The way that code works is while the public API is exported over, there's a child node process running that gets called down to. So you're still running JavaScript code when you call this stuff. All that to say, that's why you need Node installed. So a little bit of behind the scenes of how that works. Okay, so let's get into the coding demo now, the good stuff. To do that, I'm just going to make a new directory here. It's called SciFi. And delete my one from before. Let's just get this out of here. All right. Let's make dear SciFi, CD into it. And now we're going to do the CDK init. And I'll do the sample app, so we get a few files to start off with. And I'll say language C#. And the CDK init will set us up with a very basic CDK project. Okay, so let's see what that's done for us. Oops, Explorer. Okay. So as you can see, it's created a few top level things in our repo here, a get ignore, cdk.json, notably. We will go over that a little bit later. And then in our source, here's our solution and all our files and all that. So let's open this up. I'm using Visual Studio because I want to use one of the Lambda blueprints, and I believe those are only for Visual Studio. Okay. And there's only 3 files in here, not too much really. And it's just like any other C# program, where program.cs is our entry point. And you'll see they're creating an app, a stack, and then calling app.synth. And then within this stack, we're just creating a queue and a topic and then subscribing. And this will create these resources for you in AWS when you deploy this. And we will actually do that. We will deploy a Lambda, not this stuff. But the way CDK, I guess, structures an app is it creates a tree where an app is at the very top and an app has stacks, and stacks have constructs. And again, if you remember, constructs are just collection of CloudFormation resources, because by the time this is done, it will spit out CloudFormation template, and that's what will be applied to your AWS account. Another thing you'll notice is that this is being passed into everything, and this is the scope. And every construct in CDK has a scope. It basically just means what owns this thing. And this is basically always going to be the stack. Maybe very exceptionally, you'll have something else, but it's pretty much always going to be this. And for the stack, it'll be app, right? Because the app owns this stack. You'll also notice here in program, we're creating the stack, but we're not assigning it to a variable. And that is perfectly valid CDK code. It will still create this stack. You can do this, if you don't need any references from it, you just need to create it. You can do it. That's perfectly fine. And that's why this global suppressions thing is here. That would normally be a C# warning, right? Because you're creating this thing and not doing anything with it. It's a possible unassigned object created. And then the justification is constructs add themselves to the scope in which they were created. So that's what that guy's doing. So let's actually get down to creating something. Just delete all of this stuff. Let's create a Lambda. And first, I think we probably want to create the actual Lambda code. So let's create a new project for that. We will use this blueprint here because it'll create a test project along with it that I would just like to go over quickly as well. You can see these options here. These are good if you need a reference for how to do something. How do I hook up to SNS or SQS and just want to poke around or something? I'm just going to do empty function, do finish. We'll look at the test after this. Let's look at the Lambda it created first in function CS, which I'm going to rename to simple function. So the name of this class doesn't matter. The name of this method doesn't even matter. But this is what will be ran. And actually, if you're not using the context, you can remove that as well, and it will work just fine. You can get things like, you get the logger out of here. I think we won't need it. So I'll just take it out. And the tests are going to yell at me now as well. You can see they were just creating a test Lambda context. And in the test, they're just running it like a normal function because that's what it is, right? It's just a C# class and function. So, oops. Open him up. You'll notice this assembly up here. The comment pretty much explains it. It lets the input be converted into .NET types, right? So in this case, it's just a string. It's not even JSON. And we'll just keep this one how it is, just 2 upper on whatever gets passed in to keep it simple. This properties, this launch settings JSON, this is for if you were using, there's a local Lambda test tool you can use. We won't use this because we're just going to deploy with CDK and test right within AWS. So I'm going to delete that. This JSON file, we also don't need. This is as you can see, if you're deploying from inside Visual Studio or the CLI, again, we're not going to do that because we're going to deploy from the CDK. We will keep this around though, because we need this handler name, which we'll see in a moment. Okay, so let's go back to our stack. How do we create a Lambda in our AWS account? What's the CDK code for that? So I'll just do simple, I'll call it simple function, sure. And it's called a function. And you'll notice there is a function class in both CloudFront and Lambda. This is pretty common in CDK libraries to have overlapping type names like this. So sometimes what you see is you might alias your class names like that, or your namespaces like that, and that's how people will take care of that. You maybe want to fully qualify them and not alias it, handle it however you want, but it's probably something you're going to have to address at some point. Cool. I don't want to name my parameters really. And we say new function props. We're not using .NET Core 8.3.1, we're using .NET 8. And remember when I talked about the managed runtimes, this is what that is. And you'll notice there's even Java, Node.js, Python, and Ruby. So, and then Go. So we want .NET 8 though. And it needs to know which method the Lambda is going to run. And this is how you do that. And I think it actually got it correct. So we don't need this JSON file anymore. But basically the format is, we don't need this README either. It has some how-tos if you're curious about this, but delete that as well to clean our project up. Okay, and the format for this handler is the assembly name, 2 colons, the fully qualified class name, 2 colons, and then the method name. And then this code lambda from asset should be, this is incorrect, it should be the location of wherever this project is. And before I do that, actually, I'm going to rename this to .infrastructure because that's what this is. And I think that makes it cleaner. I will need to rename this in a couple of spots. Let me close these. Rename the folder as well. See if it'll let me do that. It won't. Let me unload this. And this seems a little minor, but I kind of do recommend identifying your infrastructure project somehow like this. It actually did this. Here we go. Got infrastructure there in the solution. And I will talk about this when we actually deploy. I need to change it in the CDK JSON file as well. Okay. So I believe that should be everything. Let's reload. Really wants me to have those launch settings. And I'll rename the namespace as well. Oh, and I want those to be, there we go. Top level. Cool. Okay. So we got our infrastructure project. We've got our stack. And again, this is incorrect. It needs to be simple here, wherever the proj file is. So that is, in our case, boom /source / this. Okay, now there's one more thing we need to do, which is bundle it. And the reason for this is when you publish a .NET app, you don't just have a single artifact, right? You have maybe multiple DLLs or static files or an IaC, but you have multiple things. And Lambda needs these bundled together. It needs everything for that app to work. And then you hand it to Lambda and say, here you go. Put this on a Lambda, basically. And the way you do that is with code has something called asset options here. So I'm going to say asset options. It's the S3 ones, I believe. Here we go. And I will alias that as well. And in here, there's something called bundling. And I have a snippet for those bundling options here. And this looks a little scary, but it's okay, I promise. If you're curious how I came up with this, I got it from a blog post from AWS about running .NET on Lambda. So this is using those Lambda CLI tools, though. As you can see, it's installing them. Then we build .NET, and then we run this Lambda package from those tools, which basically, as you can see, it spits out a zip of your stuff. So that's what we need from the .NET 8 image. So we say bundling equals bundling options. And there's our Lambda, and we can simplify this. Now, there's two things I want to address here. One is these. I am not crazy about this. It seems a little brittle to me. If you ever, this is a one big magic string, right? If you ever rename your files or move them around, this just breaks completely, right? So you could probably address that in a number of ways. The way I'm going to do it, I'm going to create a little helpers class here. And I have a snippet for this as well. Just look at this first function for now. I pass in a type and a string. I just use reflection to get the assembly name. And then I use that assembly name with the handler function name that's passed in to generate the full handler string that it needs. So the way you can use this is probably like simple names equals helpers, generate, get lambda asset names. You say type of, I'll need a reference to the simple lambda in this project. Type of simple lambda. And then I can say name of simple lambda dot simple function. And what is it not happy about here? Simple function, sorry. Simple function. And I want simple function. Yeah, that's what it is. Simple function handler here. So this is, a more safe way of getting these names to where if I refactor these names or move the files around, this should still work. Okay, so that's the first thing. And the second thing, you might look at this and be like, wow, Daniel, this is cool, but this is like 30 lines of code to create a Lambda function. That's kind of lame, and I'm not crazy about that. And I kind of agree with you. So this is an example of when we can make our own construct. So let's do that. We can make something like, we'll say .NET8 function. I got a snippet for this guy as well. So don't be alarmed by how much there is. As you can see, it's basically the same stuff I was doing in the stack. I've just put it inside a new class now. As you can see, I'm inheriting from the CDK Lambda function, and I made a new function props inheriting from function props. And I'm just setting some of the values on there from the get-go. So now I'll leave this in here for a moment so you can see the difference. Now all we need is new.net8 function. Say this, just call it the same thing. And then that is actually fairly close. But I want to use my my helper names. And I didn't actually put them in there before. So this is a good opportunity to do that. And it actually got this part right. It put the handler name in there for the handler name, but it didn't do the assembly name here. So let's do that. Okay, so that's the difference. This plus the simple name. So this versus all that, because we put it in our own little construct, right? And now whenever we want to create a .NET Lambda, we have this available. So let's go ahead and deploy this and see how we can make that work. So, important thing to note here, I'm in the source folder, but I actually want to be, I need to run these CDK commands wherever the CDK JSON is. So I'm going to go back one. And I'm going to run a CDK synth. And this is where this file comes into play. This app value needs to be correct because it's actually, as you can see here, going to run your infrastructure project. And because all this is doing, right, it synths. So it takes all your stuff, synths it, and you get a CloudFormation template. So, and now that I think about it, I need to log in first. So I'll just AWS SSO login. And you'll see, if your account is set up and you've configured SSO, you'll see, hey, are you sure you want to allow this thing to access your data? Say, yeah, close it down. And we're logged in. And normally, a one-time thing you have to do in every account that you're using CDK in is CDK Bootstrap. I'm not going to do it because I've already ran that. But that will create this CloudFormation stack in your account. This is just a stack, the CDK needs to be present in order to do stuff in your account. So it makes some permissions for it. It makes an S3 bucket where it puts its assets that it deploys. You probably want to turn on termination protection for this guy. You can do that just like this. And that'll make it so that you can't delete that stack unless you turn off termination protection. So I've already done that. So I'm going to CDK synth. And in the future, for this demo, the magic of pre-recording, I'll probably cut out the sections where I synth because it can get a little lengthy later in the project. It might take 2 or 3 minutes or so. But you can sort of see what it's doing, and I want to note those things. And you'll get these, hey, do you want to do file sharing at Docker? And just say yes. And you need Docker running because, again, it's bundling your stuff, right? If I go back to this. So these things are important because you'll probably be running CDK in your pipeline, right? That's the idea, is you can write this stuff locally, verify it locally, or on PRs with synth, and then deploy it when it actually gets to the pipeline. So whatever, you'll need these things installed and running on your pipeline as well. So you can see here, it bundled, it installed those Lambda tools, and pretty soon we will see some, you'll see some YAML here. Build succeeded. He's still going. This is what that .NET Lambda package does for us. You can see, it's kind of probably done some other things behind the scenes, and then eventually it's decided to publish this, which now that I see it, I believe I've already noticed an issue that will happen once we actually try to run the Lambda. But I also want to point out here that all this YAML, this is, your CloudFormation basically. So, how I saw that issue, which I have not pointed out yet, is this .NET 6 right here. We want .NET 8, and that's what we're bundling, right? Because I forgot when you use that blueprint, it is .NET 6. We don't want that. And the CDK one might be as well, actually. Let me double check that. It is. And let's just do the test as well for good measure. Very nice. And instead of doing synth again, I'm just going to straight up deploy, because a deploy will do a synth first. So normally you probably don't want to be deploying from your local into dev, right? Maybe if you are testing a bunch of little things and you just want to make sure you get the CDK code right, because you can't verify that you got the infrastructure right really until it's already out there, and it can be annoying to wait on your pipeline, you might do it then. As a general rule, you probably don't want to be deploying from your local. So again, it's running. I'll cut this out until it finishes. Okay, so now it's done, and you can kind of see some of the stuff it was creating here, right? And a good example of an L2 construct, because we didn't ask for most of this stuff, right? We just asked for a Lambda. That was it. So let's go to our account and see what happened. I believe if I refresh, it should be done. Okay, so we have a SciFi stack now, because that's what we named it here. And let's look at, we'll click on it and go to resources. We can see what resources it has. So we don't really care about the metadata, but we do have our simple function here. So I can click on that or go to Lambda, and here it is. Now you might notice it has this weird, ugly name. So what is up with that? We do see, this is what we actually named it. We do see that in there, but it's got this GUID or something on the end and the stack name. So this is important to understand with CDK. The reason, or the way it got that name, is because I actually didn't give it a name. There is a property on function called, this is function props, whoops. called function name. And you can set that. And I did not on purpose. And this is not the name, it's the ID. So if you set the ID and not the name, it will generate a name for you with the ID in it, as you saw. And there is a reason for that, and they do recommend you do that and not set the name. The reason is, if you have a resource out there already, and you make an update to it in CDK, and you push that update out, depending on what you changed, the way CloudFormation chooses to update that resource is by recreating it. And the way it recreates it is it creates a new one first and then deletes the old one. So because names must be unique, if that needs to happen, you will run into a name clash and your deployment will fail. So if you just set the ID like this, you're guaranteed to have unique names. So it's more ugly to look at, but it's probably a better practice. And, I can still tell what this is, really. So, okay, here's our Lambda out here, and let's test it. And I think I said, I'm not even passing a JSON in. I'm just passing a string. I'll say, like, my string. And I'll say test. And I get back all uppercase. So cool, it worked. Got .NET on Lambda. Now let's do something a little bit more complicated. Let's say I want to have a DynamoDB table, and I want to have a Lambda that inserts into it, right? Well, let's do that. Let's create a new project. And this time, you don't necessarily need anything fancy. I'll just use a class library. SciFi.dynamo Lambda. Create that guy. And rename him to Dynamo function. I believe I have a snippet for this guy too. Dynamo Lambda. SciFiDynamo. And now I had multiple snippets for that. I guess I expected myself to keep the class name in there. Okay, I had to correct my snippet there. So I'll put this in there, and then we need some NuGet packages as well. And I got these from one of the template projects it gives you. It's a pretty good reference. And you'll notice this here, which the comment, again, pretty good explanation. It's already available in that .NET runtime the Lambda has. Some of the packages like dependency injection. So you save some space by not having to include those in your specific project. And we don't need the API gateway events in this one. So you can see, we've got some Amazon packages. Dynamo. There's one for .NET Core and the annotations package, which we're using now. So you can see here we have a Lambda function being used. And we missed that. We need to have that assembly attribute. There we go. Okay. So this does what we want, right? We are calling a put item into Dynamo with using just a GUID for the key for demo purposes, and then whatever item we pass to the function, we say we're going to insert that in the table. Now, we have a few problems here. One of them is this. If you remember, is that Lambda requires you to have a parameterless constructor. And we could, straight up right here, new up a DynamoDB client and use that, and it would work. But we don't really like to do that in C#, right? We like to inject our dependencies and then we can mock them out in our tests. But how can we do that if we need a parameterless constructor? It's kind of hard. Well, this is where annotations come into play. And we need a startup CS class for this. It is required to be called startup. And it's pretty much like a normal startup, right? You have this configure services method. There's this Lambda startup annotation. It says indicates the class will be used for registering service that can be injected into Lambdas. Cool. So I'm calling this add AWS service of Amazon DynamoDB. And then I'm having an Amazon DynamoDB in my constructor. So what those annotations will do is it will use source generation to create a parameterless Lambda, and still, at build time, you can effectively have dependency injection. So you can just test this guy as normal, right? So the one thing we need to be cognizant of with that is that our handler, for whatever reason, the handler string looks a little different with this. This serverless template, again, we don't need this, but useful for seeing what our handler needs to look like. As you can see, it's got some underscores now. It's got underscore generated, so it just looks a little different. We need to be aware of that. Now, unfortunately, even if I delete this guy, if you have, for whatever reason, if you have this annotations package in your project, whenever you build, it thinks you need it, and it puts it back in there. So, you can put that in your git ignore or something, but it doesn't hurt anything. It's for if you're using SAM, and we're not. So, okay, that's one problem. So we've solved that. The other problem is this. How are we supposed to get the table name, right? I've kind of put one piece of the puzzle there for you with the environment variable, but we don't know the table name at build time because it's generated by CDK using those generated names I showed you. So how can we possibly get it in there? Well, to answer that, let's go create a Dynamo table in our infrastructure, in our CDK code. Let's go to our SciFi stack, create a var table equals new table. I will alias that as well. I'm going to say Dynamo. This, I'll just call it my table. New table. And now that I think about it, I believe I have a snippet for that as well. So it's supposed to save me some time. And I believe the only thing you need to have on this guy is a partition key. Everything else is optional. So I don't need to set these, but, just kind of show you some options on there. And I do want to point your attention to removal policy. So this one is retain by default anyway, but I'm setting it explicitly. Removal policy. What is removal policy? So whenever there's also a CDK destroy command. And this might be this might be something you need to run sometimes, depending on the situation. But you should be prepared for your stack being deleted. Well, when this happens, any stateful resources you probably don't want being deleted, right? So Dynamo, S3, things like that are stateful. Anything that holds data. If those were to be deleted, you would also lose all your data. Pretty not good. So the default removal policy for these is retain, which means the delete still succeeds. The stack is deleted, but in this case, this table would be orphaned from the stack, and then it would stay in my account. So there's some other options here, like destroy for, I think, the stateless stuff. This is the default. There's also like snapshot, like delete it, but take a snapshot first. And normally you probably just want retain for your stateful stuff. And I believe on the stateful resources, that should be the default anyway on all of them. But that is an important concept to be aware of. And in fact, it's so important. What people do a lot is create a whole new stack for their stateful stuff. So let's do that. So, I create a new stack and just inherit from stack and give it the constructor it needs, and everything goes inside that constructor, just like in our other stack. So I'm going to move this table into there. And, as you can imagine, this, I'm not going to do it, but this would probably also be a good opportunity for an L3 construct. Like something pretty common with Dynamo tables, I think, is you want to have it encrypted. So we could have like key equals new key from KMS, alias it, new KMS key, and I'll just say I'll say like table key. And the key props on this, pretty small. Just want to enable key rotation, true. Okay. And then down here, I say encryption equals customer managed, and encryption key equals key. Fairly common also to want to tag your resources in your account. A lot of times it's used for budgeting purposes. And the way you do that is just tags.of. And you see what it did to me there. That's the wrong tag, so you got to be careful. There's one in the CDK package. So I'm just saying tags of table. You say add. Just say like my key, my value. Pretty common use case. Okay. Cool. So we've got a table here, and it's in a separate stack now, and that's another problem, right? There's two things going on. We want the Lambda to have access to the table name, and we need the Lambda to have the permissions to the table. So we need a reference to this table in this stack where our Lambda is. So the way we do that, let's go back to our stateful stack. I'll say public read-only Dynamo table. I'll call it my table. And then down here at the bottom, I'll say my table equals table. So we can get it out of here now. So let's go to our program where our app is being created. We need to create a stateful stack first, right? Stateful stack equals new stateful stack. App is the scope. Call it, whoops, stateful stack. And then now we have that my table, right? So if you noticed, stacks also have props. So we're going to create a stack props for our SciFi stack. And okay, I couldn't remember if I had the snippet for that or not, but I've got copy paste snippet, which is pretty close, right? So I'm inheriting from stack props, and I just made this a one-liner because it's such a small class. The only thing I needed it is the table. I'm just making it get in a init to be more safe. Instead of an iStack props, I'm going to say, let's rename this to SciFi stack props. I'm going to say SciFi stack props. Probably know they're not going to be null anymore, so I'll take that out. Okay, and then I pass in, or I make a new, let's see, SciFi stack props, yes. Couldn't remember the name. SciFi stack props. And I say my table equals stateful stack my table. So now it's being passed in, right? So there's two things we need to do. Give the Lambda the table name and give it permissions. So let's do the table name first. And I believe that is a property on the function itself called env. No, it's called environment, not env. So maybe it's on the props. Yes. And that's the nice thing about making my .NET 8 function props. And it's just the normal function props. So I can still override all the normal function props properties if I need to. And it actually got that right. So that was impressive. Yeah, let's just name it that. And we are inserting an environment variable into our Lambda with a key of table name and a value of whatever CDK names our table. And I believe I actually did call it that in our function. I did. Cool. And, you know, you could abstract this out into its own interface if you wanted to, and inject that as well through Startup CS, and it would be more testable. I won't do that for the coding demo to keep things shorter, but we also need it to have permissions, right? So we just say props, my table, dot grant. You can see there's a variety of permission sets we can grant. We just need to write. We're just putting into simple function. Sorry, I didn't create our dynamo function. This is still our simple function. So we'll just do that real quick. SciFi dynamo. That's okay. It's so small, it won't be much work. Say dynamo names. Reference to this in the project. Dynamo function, still called function handler, and we'll call this dynamo function. Just a bunch of renaming. Use the dynamo names. I think I'm missing a parentheses here. There we go. Okay. And remember, this is a source-generated function, and that's what the other function in here is for. It's just get generated lambda asset names. And as you can see, I've got the underscores and generated in here. So I will use that one instead. Get generated lambda asset names. And we want this and this one. There we go. Okay, and we don't want it in this one. This will remain simple. And grant write data will go to our dynamo function, and that's it. This will create a few permissions. It's like put item and batch stuff, but if you wanted to be super locked down, you could by hand write an IAM permission for inside this code that only grants it put item. My opinion is that's not usually worth the squeeze. If it can write to the table, it can write to the table, right? Okay, so let's deploy this and see if everything works as expected. So again, I will do a CDK deploy. And one thing to note is I need to do an all now because I have more than one stack. If I have more than one stack, it needs to know which stacks to deploy. And I want to do all of them. So I'll do -- all. And again, I will see you when this is done. Okay, so now it's finished. I ran it a couple more times because I set the timeout duration to 10 seconds. I think it's 3 by default. And in my experience, combined with the cold start time and that dynamo call, sometimes it failed. It took more than 3 seconds. In my stateful stack, I also set termination protection to true, since it is my stateful stack. Same concept as when I set it on the CDK bootstrap. So let's go look at our functions. And then we do have 2 now. We have our new dynamo function. So let's go into that. And let's look at DynamoDB2 to make sure our table is there. And it is. There's our table. No items in it, but let's see if we can change that. So test. And again, we'll just give it like my string. And test. You see it already took past the 3 seconds. So, okay. So we still had it return the uppercase, but what we really care about is if it inserted into the table correctly, and it did. So as you can see, we were able to successfully inject our dependency of DynamoDB with that annotations library, even though Lambda requires a parameterless constructor. So pretty cool. Now the last thing I want to show you is going to be how do you make an API with a Lambda. And again, we're going to make a new project for this, just a class library. We'll call it SciFi API Lambda. And we will not need the startup class for this. I'm not going to do anything fancy in here. I'll call it, I guess, API Lambdas, because we're going to have multiple in here. And then a snippet for this. Yeah, there we go. That one. And again, we will need to add in those NuGet packages into our CS proj. So I'm just going to paste that same one in. This time we do need API gateway events, but we don't need DynamoDB. So, and we need our assembly attribute. Always forget the assembly attribute. Okay. So, you will notice that even though this is only one class, we have multiple Lambda functions. And it's important to note, there's 3 Lambda function attributes in here. This will create 3 functions, okay? And we have a REST API attribute now on our methods with routes, right? And this is Lambda annotations again. And I won't show you all, I won't code out all the boilerplate it saves you, but in their docs page for annotations. So here's what we're doing, right? If you're not using annotations, this is what you have to do. This is the equivalent code for this. You can't just pass in X and Y. You have to take an API gateway request, and then you have to verify that the X and Y were there, that they were ints, and then you can't just return X plus Y. You have to return a response with all these things. So it saves a bunch of boilerplate code. It's pretty nice. It's just one of those things that just works. And okay, so there's our API lambdas. Let's go put them in our stack. And we're going to create an API gateway as well. Now this is kind of a big snippet, but don't be too scared here. I'll explain it. API, I named it functions, plural. I believe is why I named it API lambdas. Let's just name it API functions, plural, sure. There we go. Okay. So let's break this down here, because this kind of looks like a lot. Well, we know these, right? These are just making lambdas. And we're making 3 of them, like I said, because there's 3 routes. There's 3 lambdas in here, right? So we're making the root, which is the root one here. And we have an add one and a lower one. So we have an add lambda and a lower lambda. And really, it might be easier to understand this if I put the API stuff after all the lambdas. So I'll do that. I'll do that this way. Maybe this makes more sense. And this is a good example of an L3 construct that is provided for you. This is a REST API that is backed by a Lambda. And that's exactly what we want in this case. The handler is the default handler for all requests that aren't defined. So this will be our root, and if we get anything that isn't, for a route that isn't set up, it will go to this default handler. And then the way we add other routes is we say api.root to add resource, add, then we add the X and the Y and say it's a post. It's a Lambda integration, and it's our add function. Same thing for the lower. We don't have quite as many parameters there. The one thing different with the lower is that we're using from body, and this will also work, right? So let's, like I said, that one will be fairly quick. So let's deploy that now as well. And I'll see you when that's done. Okay, so here we are. It's done now. Let's go into our account again. We can close out of this Dynamo table. Let's see if our new functions are here now. Here they are. We have 5 now, right? Because we already had 2 and we made 3 new ones. Now, I'm going to call the root is easy to do because it's just a get, and it just, I believe, it just returns us a number. Yeah. Sometimes when I CDK synth or deploy, I notice I have to rebuild everything, or I get a bunch of, it doesn't know what everything is. So, not sure what CDK is doing to me there. And here from the templates, I'll say AWS gateway, API gateway, AWS proxy, just send it through. Usually it just gave us 5 back in the body because we just told it to return 5. These, however, are posts. So I'm just going to use curl for those. So for the add, let's do this. And that is an old URL actually. This is a good explanation anyway. So you'll notice I have an output for my stack now, which is the URL of my API gateway. So I'm going to use that in my curl command. So it'll be almost this, but the URL will be different. Take that, paste it, and there we go. Oh, why do I have dash data in there? There we go. So there we go. So it worked. I gave it 5 and 3, and it spit me back out 8. And let's try the lower one as well. Take this guy. Oops, this guy. And he should give us back a lowered string, right? And he does. So our API is up and working. It's running our Lambdas. One thing to note, which I'm not going to include in this demo, is you can actually run ASP.NET Core on Lambda. That works just fine. And you can also have one Lambda handle multiple routes. I believe if I take a look at the templates, by the way, it's quite a few templates. So it starts here. As you can see, there's quite a few in here if you want some examples of things to look at. For us, I want to, there is an example in here that shows you ASP.NET Core. Somewhere, here we go. I will choose this one. Just say ASP example. I'll delete it afterwards. Just kind of want to show you that it's possible. And, you still even have your controllers, right? You go and look at it, and, it just looks like a controller, really. We have our Lambda entry point. Not going to go through all this stuff, but you have a Lambda entry point, and then you have a local entry point, right? And this looks pretty familiar, the local entry point, so that you can run it locally, right? And then again, you just have your startup class, which also looks completely familiar. So the .NET support here is pretty solid, in my opinion. There's even a, app settings JSON. This is pretty much just a normal project. And anyway, that concludes the demo. So we went through setting up a Lambda talking to Dynamo, and Lambdas with API gateway, and how to do that with CDK, create our resources, deploy them to AWS, all while staying in C#. We don't have to use JSON or YAML or anything else. We can all do it all within our IDE. Okay, so back to the PowerPoint here. And we're about done. The last thing I want to mention here is this idea of cattle, not pets. And the best, as best I could tell, this was coined by Bill Baker in 2011 or 2012 when he was talking about scaling up versus scaling out. I noticed I did not include the blog post link on here. I got that from, so I'll do that if you go to my site and look at this. But basically, the idea here is you want to think of your infrastructure as cattle, not pets. The difference here being, pets, irreplaceable, cute. You name your pets. You manage them yourself and your servers. You might even give your servers individual names, right, when you refer to them. And if you are not automating your servers, if a server goes down, that's a big deal. You get people to go in and fix it right now, right? Well, really, you want to treat your servers like cattle. They're replaceable, and I guess they're okay. They're maybe sort of cute. They're fine. Cattle, you don't name them. You might number them and put them in groups, but you don't give them individual names. And they're not you don't manually manage each one, right? They're automated. So you should be totally prepared for a server to go down to handle that in an automated way. And you have that, in my opinion, if you are completely comfortable doing this. And if you can do that and you're like, it'll get stood back up again, or we can just CDK deploy and everything is exactly the same, that's what you want. That's when your infrastructure is really safe, right? And I think a lot of people at this point have heard of things like chaos engineering. You go into your account and purposefully take down production services to see if they recover correctly, things like that. And this helps us reach that. So just recap, we went over why to use .NET and AWS, basically because those are the things you're familiar with. Some of the tooling like templates and CLI tools available to you, some of the community options you can find, the fact that AWS supports native ahead-of-time compilation. Obviously, we went through a lot of CDK, how to use it, and talked about cattle versus pets at the very end. And in the demo, we saw a bunch of the CDK. We made some C# lambdas, saw those lambda annotations in action, how much effort they save us. And we connected to DynamoDB and API Gateway as well in our lambdas. So that's it. Thank you for listening, watching. Again, you can find me on the socials and at my blog, daninacan.com. So, yeah, thank you.